Hello. Today we're going to take a look at advanced factoring. So there's a couple of different methods that I'm going to show you today. Some of them are pretty hard and it can be kind of situational depending on what it is that you're looking at. So we're actually going to jump right into it here. So we're up to lesson 61. Recall that synthetic division is used to divide a polynomial p of x by a linear binomial in the form of x minus a, and that the number in the bottom row is the remainder and also the value of p of a. So if the remainder is 0, the linear binomial is a factor of the polynomial. This is known as the factor theorem. So if we have a polynomial and we use synthetic division or divide by x minus a, and we get no remainder in the end, that means that our answer would be kind of like what is left over, and whatever we divided by, that would be a factor of that entire polynomial. So let's take a look at this. We have 2x cubed minus x squared minus 43x plus 60, and we want to divide that by x minus 4. So remember, whenever we're given a binomial in synthetic division, we are going to use that opposite term. So we're going to use 4. So I'm going to set up my synthetic division here. On the outside I'll have my 4, and then I'll have a 2, a negative 1, a negative 43, and a 60. Remember, synthetic division, we're just going to drop that straight down, multiply that by 4, so we get 8. Add these two terms together, so we get 7. Multiply by 4, so we get 28. So then let's see, that would be negative 15. Multiply by 4, and we would get negative 60. So because this last term is 0, or these would cancel each other out, our remaining little piece here, since x cubed was the highest power, this drops down 1 power since we divided by a linear binomial. We have 2x squared plus 7x minus 15. So that would be kind of a piece that's left over. And then, since we divided by x minus 4 and didn't get a remainder, that means x minus 4 is a factor of that. So if I redistributed that x minus 4 into that 2x squared plus 7x minus 15, we would be left with what p of x started as. So that entire lengthy polynomial there. Okay? So let's try another one here. So that a value is going to be negative 3. And then we are going to have 1 and 1, negative 24, and positive 36. So we'll drop that straight down. We get a 1, multiply it by negative 3. Add our two terms together and we get negative 2. Multiply those to get a 6. So then we'll have negative 18. And our last little piece here, 8, 16, 24, it looks like a positive 54. So we get 90. So because when I went through all my steps, that 90 is a remainder. So since 90 is a remainder, this x plus 3, that is not a factor of our polynomial x cubed plus x squared minus 24x plus 36. So in order for that to be a factor, we have to have no remainder in the end. So let's take a look at another method of factoring. And this is going to involve cubes. So we've done sum and difference of squares. There's also factoring methods for sum and difference of cubes. So we have when the remainder is 0, the quotient of p of x and x minus a and is another factor of the polynomial. This factor may be able to be further factored by other factoring methods. For instance, in example 1a, the quotient 2x squared plus 7x minus 15 factors down into 2x minus 3 and x plus 5. So for our very first answer, if we were going to continue to factor that down, this would be the completely factored version of what that might look like. If the remaining quotient is a cubic, it may be factorable by one of the following factoring methods. So we have a sum of two cubes, or we have a difference of two cubes. Kind of the same way we have a sum of squares and a difference of squares. So in the sum of cubes, you notice we have a and b, so we would have to figure out what those are, because one of them could be a number that is already cubed. So we would just take out an a plus b, and then what would be left over would be a squared minus a times b plus b squared. And then vice versa, if we have the difference of two cubes, we would have a minus b, and then that would be a squared plus ab plus b squared. So a tricky thing to remember if you're doing sum or difference of cubes is that in the difference, the only minus that we're going to have is 1 in the fact that we're doing a difference of cubes and in the piece that we're taking out. In the sum of two cubes, the only minus we should have is right in front of that middle term in the trinomial. So let's take a look at a couple of these. Okay, so this first one, d cubed plus 125. We would need to find the cubed root of 125, which we should be able to figure out as 5. So this would factor down to d plus 5, and then we would have d squared minus 5d plus 5 squared, or 25. So that's what that piece will look like there. Now the second one, you notice we have that 27x to the 6th power and then a y to the 9th. So we're kind of breaking that down. So that 27, again, I can still tell that this is a sum of cubes. So I know 27, or the cubed root of 27 would be 3. And then if I broke that x to the 6th power down into 3 equal parts, that would give me x squared in each of those. So simply my a term is going to be 3x squared, and then my b term would be y to the 3rd power. So using this, I should also be able to come up with the rest of my factored piece if I'm following that rule. So it goes a squared, so I'm going to do 3x squared squared, so that'll be 9x to the 4th, minus, we'll have 3x squared y to the 3rd, and then plus, that'll be y to the 6th, because it'll be y to the 3rd squared. Okay, and then moving on to that last one. So a couple things that throw off some red flags right away to me would be the fact that we have m to the 5th, and then our other little term has an m squared in it. So that kind of tells me that we're going to have to do some pre-factoring, and also I know that 3 goes into both 3 and 24. So we should be able to take out, it looks like a 3m squared. So if I do that, I'd be left with a m to the 3rd power and 8. Okay, so then this is going to be a difference of cubes, which this piece right here, that m cubed minus 8, I'll rewrite my 3m squared We'll move on over. So that's going to be in m. I know that the cubed root of 8 would be 2, so I'll have m minus 2, and then this will be m squared plus 2m plus 4. So this would be what our entire little piece factored down would look like. Moving right along, another method here, factoring by grouping. This is a pretty good method to use if you are dealing with a polynomial that has 4 or 6 terms in it. So factoring by grouping means that from descending order, so starting with the highest power down, I'm going to group these into 2 kind of binomials, and I'm going to take as much out of each of them as I can. So that first group, I can take out an x squared, and then I have a x plus 5 on the inside. Okay, so this other piece, or the second group I should say, I can take a 3 out, and then again I'm going to be left with an x plus 5. So these two things right here need to match up in order for this to work. So that kind of tells me that I can do factoring by grouping. So my two factors, since those two match up, x plus 5 is one of them. And then my second little factor would be this, what's left over or what I took out put together. So we would have x squared plus 3. So that would be my final answer there. Now let's take a look at this next one down here. Again, I'm going to factor by grouping. So that first one I can take out x cubed. So that'll leave me with a x plus 4. Now in the second group, it doesn't really look like I can take much out, but remember, based on what I just told you, we're trying to get an x plus 4, so I have negative x minus 4. So I'm going to take out a negative 1, and that would leave me with x plus 4 on the inside. So again, we would have x plus 4 would be one of our factors because those are two things that match up, and I wrote 5. So x plus 4. And then x cubed minus 1 would be our other piece there. And then actually, since I have x cubed minus 1, that's actually a difference of cubes. So we can take this one step further. Since 1 is kind of a special number, so I'm going to write, we'll have x plus 4. That's a separate factor. So then I would have x minus 1. And then I would have x squared plus x plus 1. So that would be all of our factors of that one there. We'll try a factor by grouping of a little bit bigger of a piece here, or a bigger polynomial. So again, we have three things total. So if I am looking at this, it looks like the first group, I should be able to take out x to the 4th. And that leaves me with x squared plus 3. You know what? There is a typo in here, because this won't work. So this should actually be a 2 at the end. And then I'm able to factor by grouping. So I have the problem written down wrong, so I apologize for that. But the first one, like I said, we can take out an x to the 4th. That'll leave me with x squared plus 3x plus 2. Then I already have, that's what I have in the in the second group is the x squared plus 3x plus 2. So we can say that we're just going to take out a 1, and that's not going to change anything. So we'll have x squared plus 3x plus 2 again, and then we will have x to the fourth plus 1 as a factor, and then we'll have that x squared plus 3x plus 2. Okay, then also this x squared plus 3x plus 2 can be factored down even further, because we can say what is going to multiply to get 2 but add up to get 3. That would be an x plus 2 and an x plus 1. So lots and lots of factoring today. Lots of different methods. Make sure that you take some time to do each of them slowly. Give it some time. Remember, the first time you're trying to learn how to factor, it's going to take some practice. So we have the volume of a rectangular solid with a length of x minus 5 feet has a volume of x cubed minus 23x squared plus 170x minus 40 cubic feet. Factor the expression for the volume completely. So to do this, it's jumping out at me that since we have a length of x minus 5, we have a binomial term, so I'm thinking that we are going to use synthetic division. So we have 1, we'd have a negative 23, we'd have 170, and a negative 400. So we might have to do a little bit of mental math over here, but that's all right. Bring the 1 down, multiply by 5, we get a 5. We'll have a negative 18. This will be negative 90. And then we will have 80. 80 times 5 will be 400. So not too bad. From here, so we know that x minus 5 was part of it. Our volume is this entire thing. So we didn't find out too much. All we have is a length. So that broken down, we would have x squared minus 18x plus 80. That would be our next kind of piece to our puzzle. If I have that negative 18 in the middle, if I'm doing my old ways of factoring, what multiplies to get 80 but adds up to get negative 18, I'm going to say a negative 8 and a negative 10. So we can say that one of those is the width, one of those is the height. Doesn't really matter. So that will be that one. I hope you guys learned something. Remember, you can go back and always take a look at something or pause it or replay it if something didn't make sense. But I hope you gain something out of this lesson, and I hope you have a great rest of your day.